Hey, ladies and gentlemen, welcome back. The first stoichiometry video, we talked about mole to mole, mole to gram to mole, and gram to gram problems. This last video, we're going to talk about using molecules in our calculations as well as volume. So the first one, it says calculating the molecules of a product. So it says how many molecules of oxygen. So we'll put question mark molecules above are produced when we have 29.2 grams of water is decomposed by electrolysis according to this balanced equation. So we start what we know, and we know we have 29.2 grams of H2O. Now remember from last video, you can't go straight from grams of something to your mole ratio, so you need to go from grams to moles. So times 1 mole of H2O all over 18.02 grams of H2O. Now, we're at our easy past station. We're ready to go over our bridge, use our mole ratio. So we have times 1 mole of O2 all over 2 moles of H2O. And you're thinking, where do I get these numbers from? I get these from our balanced chemical equation. So now we're in moles. We want to go to molecules. I'm going to put this down here just to save space. So 1 mole will be on the bottom of O2. Now, we're dealing with molecules. So we know when we're dealing with molecules, we want to use Avogadro's numbers. So 6.022 times 10 to the 23rd molecules O2. So we plug this in our calculator. We have 29.2 divided by 18.02, hit equals, divided by 2 again, hit equals, and then times 6.022 times 10 to the 23rd. And we get around 4.88 times 10 to the 23rd molecules of O2. So that's using molecules. So anytime you see molecules, think of Avogadro's number. Now, let's use some volume stoichiometry. So, as we look at this problem, it says nitrogen monoxide and oxygen gas combine to form the brown gas nitrogen dioxide, which contributes to chemical smog. How many grams of nitrogen dioxide are produced when 34 liters of oxygen react with an excess of nitrogen monoxide? Assume conditions are STP. So these 3 capital letters mean a lot. And we know from our mole to volume relationship video, 22.4 liters over 1 mole, or 1 mole over 22.4 liters. Now, I'm going to erase this. Just want to reiterate that quickly so we have enough space. Now we start what we know, and we know 34 liters of O2. So since we're at STP, we know in 1 mole of O2, we have 22.4 liters of O2. So now we're in moles with our easy past station. We're ready to go over the bridge. So times 2 moles of NO2 all over 1 mole of O2. Now the last step, we want to go to grams of NO2. We just need to calculate the molar mass. So we have 14.01 plus 32 gives us 46.01 grams. So we plug this in our calculator. We have 34 divided by 22.4. It equals times 2 times 46.01. It equals, and we get around 139.67 grams of NO2. Okay, so two more examples we have here. So it says, assuming STP, how many milliliters of oxygen are needed to produce 20.4 liters of SO3 according to this balance equation, right? Key thing here, STP. So we have 20.4 liters of SO3 times 1 mole SO3 all over 22.4 liters of SO3. So now, it's been a long journey. We got to our mole ratio. Got to our easy pass station. Now we want to go over the bridge. So we have 1 mole of O2 all over 2 moles SO3. And I'll put this right here. So we know in 22.4 liters of O2 over 1 mole of O2. And then the last step, we want to go to milliliters of O2. And we know in 1 milliliter, we have 0.001 liters of O2. So we calculate this, 20.4 divided by 22.4, hit equals, divided by 2, times 22.4, and then divided by 0.001, and we get a pretty big number. We get 10,200, or 1, 2, 3, 4, 1.02 times 10 to the 4th milliliters of O2. All right, and then one example to finish our video off. So it says, what volume of water? So it just says volume. Right now we'll just say we want to go to liters. Is produced at STP by burning 501 grams of methane. So we start with our 501 grams of methane, CH4. Change those to moles. So times 1 mole of CH4 all over 16 16.05 grams of CH4 at our easy pass station here. Now we're going to go and use our mole ratio. So times 2 moles H2O all over 1 mole CH4. So this is what you want to go to volume. 1 mole of H2O will be on the bottom. And on top we'll have 22.4 liters of H2O. So 501 divided by 16.05, it equals, times 2, it equals, and then times 22.4, and we get 1,398.43, or 1 can round that to 40 times 10 to the 3rd liters H2O. And that concludes our video on stoichiometry.